this is that if we have some vector valued map and we know that its Jacobian is invertible around a point, then we can sort of solve for some of these variables in terms of the other. It's a very general statement and is used in geometry quite a lot from what I remember. And he uses this to discuss a lot of the things about this system of ordinary differential equations. So
basically you have L equations for L variables Z. So these are L equations for L variables, and it basically tells you when this is solvable. If the Jacobian here by dz is invertible, then it is solvable. It doesn't mean that you can find that function, but you know that it exists, it is defined in the neighborhood of that point. That's all it says. So just write down non-linear equation, L of them. Then if f of x is equal to, because it takes values 1, 2, 3, there are L. In the right hand side, u0 is just some fixed, you could put 0 there. And then you could solve it as z as a function of x, basically. That's all it says. And the proof of that uses the inverse function theorem that we stated before.
So, and then it picks up, I'm not sure it uses that for some time, but it picks up talking about constant coefficient systems of this form, and exponentiation of matrices, and then continues.
Linear systems.
Yes, linear constant coefficient. Yeah, and I think that's what a deal we'll talk about in a week. I will try and get a website up. If I don't have your email, let me know it. And then I will email everyone. If you need a copy of this book, again, we have access to it through Springer online, through the Libros catalog. So I can give you a link to that that's accessible on campus. I will try and put a list of these seminars up on a website and get that to everyone, maybe by Sunday. And if anyone wants to present in 2 weeks, let me know as soon as you can, and we'll sort of maybe discuss with Adil how far he thinks he will get. And then if not, if Dr. Evermedia wants to.
If you do the schedule, you could put the sections
Right.
in advance, and then the names of those who volunteer would fill it in, and then date, and so that the people will know what the schedule is.
Right, and if it'll probably be rough. Again, I originally had intended to get through section 5, and I barely covered section 3. Part of that was because I just didn't have enough time preparing. So if things need to change, I think that's fine. It's very loose. It's not a very formal seminar, I think. That would be maybe a better...
Are there any questions you should ask if there are any about what we presented today?
Or about the format of the seminar, any suggestions, any ideas?
Yeah, is the proof of the implicit function theorem simple enough that at some point you could go over it in class, or is it sort of outside of scope?
It's complicated enough that, again, it's not seen in any undergrad course here. It's not incredibly complicated. It is a few pages in this book, I think.
By the way, there is a very good book if you're interested. It's called, the author is Spivak, and the book, it's a little book that's called Calculus on Manifold. And it's kind of upgraded version of Calculus 3, if you want. It's a calculus of multiple variables book. And it is proved there, for example. For those who are interested, I think that book should be the first book to read. Very nice book.
What was the other name again?
Spivak, S-P-I-V-A-K. And it might be even in the library. And it's little, paperback book.
Is this one of these Dover books?
I'm not sure, I have it in my office, I can show it to you.
So I
Maybe
think
there is
Dover, it's a different formation.
Yeah,
It's not Dover.
something on the chair.
So I think because we're trying to get at PDEs, we probably won't cover the proof of the implicit function theorem. For the first chapter specifically, we will probably be very light with what proofs we show, just because personally at least, I would like to get through the background information so that we can have a
I
PDE
agree
seminar.
with that you should do in class just exposure of the ideas, and those who are interested may go and read the proofs, and if you find something interesting, you could share them later, the ideas. I mean, so that move a little bit at a reasonable pace, otherwise you would spend a lot of time on those proofs.
Okay.